सर मैंने आपको ईमेल किया है क्योंकि वो व्हाट्सएप इसका दूसरा मोबाइल में लाया नहीं ना। नॉर्मली पहले अपने आप को व्हाट्सएप करता हूँ दूसरा।
फोन भी महंगा इसमें ज़्यादा डर लगता है, हमारा फोन गिरा तो नहीं लगता है, ज़्यादा ठीक जाती है।
ये स्लिपरी भी ऐसे ऐसे थोड़ा कैसे
नहीं, ये
फिसल
थोड़ा सा
जाता है, यहाँ से थोड़ा सा फिसल
थोड़ा दबाने को
चालू हो रहा है। सर कुछ बोलिए, कुछ लिखिए सर। शेयर कर दीजिए। नहीं अभी हो गया, हाँ टाइम लगेगा।
अच्छा सर लाइव काफ़ी तेज थोड़ा हल्का हो रहा है से लिंक भेजता हूँ जनरेट कर करना चालू कर
क्यूब एंड डाइस।
जैसे माइक्रोफोन डायरेक्ट आ जाएगा, वॉइस वो बॉयर नहीं लगा।
नहीं वो मैं आपको एयरपोर्ट ला के दूँगा।
पेन हल्के लग रहे मुझे, ये पेन थोड़ा हल्का हल्का लग रहा है, बाकी पेन देखना एक काम करना, ये ग्रीन तो यूज़ मत करना। तो ब्लैक अगर हल्का हो रहा है तो दूसरा पेन ट्राई करना, हल्का सा बस आगे बढ़ना इससे
All set.
So good morning students. So today's session we are going to start with cube and dice. So first we'll see what is the cube and then we'll see what are the problems that we can solve with the help of a dice. So first of all, what is the cube? What is cube? It's like a square box, right? Can we say like a cube is something like in which all of its sides are equal, right? So we can say that, let's say I have a cube right here. So you can see in this cube that, so if I talk about a rectangle, so rectangle is a 2D structure, right? So there is no height associated with it. But in the case of cube, there is also a height is also coming, right? So if I ask you what is the difference between cube and cuboid? What is cuboid? Cuboid is also a 3D structure, right? But there is a difference between cube and cuboid. What? A rectangle, right? You can say like it's a rectangle box. or cube is like a square box. So can I say in a cube all sides are equal? This length, breadth and height, L, B, H all are equal. Yes, coming. Good morning, good morning. This is length, this is breadth and this is height. So we can say cube is nothing like a square box. Okay, but in case of cuboid it is like a rectangle box. Okay, so we can say like a cuboid can have two sides same. Cuboid can have two sides same. So if I say in case of a cube, this is nothing but a, this is also a and this is also a, right? So, but if I talk about the cuboid, then it can have maximum two sides same, right? If I say this is 3 centimeter, for example, this is 3 centimeter and this is 4 centimeter, then it is called the cuboid. So we can say if any of the side is, if all sides are equal, then it is called the cube, right? If any of the side is not equal, I can say, let's say all are unequal, right? Let's say this is 3 centimeter, this is 4 and this is 5, then it is called cuboid. Even if two sides are equal, right? So this is 5 and this is 7, then also it is called the cuboid. To become it a cube, what is the condition? To become it a cube, we should have that all sides is equal. Is it clear? First thing is clear, right? We all know what is cube and all. Okay, let me ask you the basic question. First of all, tell me what is the total surface area of cube? 6a square. Why it is 6a square? All of you know that. Because it consists of 6 square faces, right? And what is the area of one square face? A square. And there are 6 faces. So I can say this is 6a square, right? And next thing, if I ask you what is the volume of this cube? A cube, right? Because A into A. Okay. In general, if I ask you what is the volume of any 3D structure, we'll say base multiplied by height, right? Or we can say the area of base multiplied by height. So what is the base here? Square, right? So what is the area of square? A square. And what is the height? A. So A square multiplied by A. And what is A square multiplied by A? A cube. So this is how we get the volume. Simple, right? If you talk about any structure, let's say if I want to find the volume of a cylinder, what is it? Pi r square into h. How we got pi r square into h? Because pi r square is what? Area of the base. And what is the height? Perpendicular height is h. Clear? If I ask you what is the diagonal length? What is the length of the diagonal? This diagonal? I told you now how many diagonals. Okay, first of all, tell me how many diagonals do you have in a cube? How many diagonals are there in a cube? Anyone? Maybe from the last. How many diagonals? 14. Think about it. How many diagonals are there in a cube? 4 only. Just. I think this thing we have discussed in the last class also. How many diagonals are there? There are total 16 diagonals, right? How 16 diagonals? You see. Can you say in a rectangle or square, how many diagonals are there? 2 diagonals, right? So how many squares are there? 6 faces, 6 square. So can I say this will have 6 into 2, and these are called the surface diagonals, right? Because they are made on the surface, right? And can I say there will be 4 more additional diagonals? You see, if I join the top vertex to the downside, one diagonal get, and likewise this. From these 2 vertex and these 2 vertex, I'll get the total 4. So how many diagonals I have total? 16 diagonals. So there are total 16 diagonals. Okay. But if I am joining this vertex to that vertex, and that diagonal is called the body diagonal, right? There are 2 types of diagonals. One is the surface diagonal. Another one is the body diagonal, right? But if I ask you, whenever I say diagonal, it means that I am finding the length of body diagonal, right? So if nothing is mentioned, so by default, I am finding the length of body diagonal. So first of all, tell me what is the length of body diagonal? All of you have studied, right? This a root 3, right? This one is fairly simple. But if I ask you, what is the length of this diagonal? Can you find the length of this? What is the name of this one? Lateral diagonal, you can say. It's a surface diagonal also, right? Or you can say face diagonal. But in total, if someone asks you how many diagonals are there? 16. Out of which 12 are surface diagonal, and how many body diagonals are there? 4 body diagonals. Is it clear? Now if I ask you, can you find the length of this diagonal? That is AB. How can you find the length of this diagonal? This one is fairly simple, right? A root 3, this thing you have studied, right? So this is nothing but the length of body diagonal. And this is nothing but joining this vertex P and B. So I can say this is the length of PQ. But if I ask you, how can you find the length of surface diagonal? So can we apply the Pythagorean theorem here? Can I say this is 90 degree? Clear? And what is this length? A only, right? Because the each side is A only. This is also A. Now if I apply the Pythagorean, can I say AB is nothing but A square plus A square, right? And what is this? A root 2. Clear? So surface, this is nothing but the lateral diagonal or surface diagonal. And what is this one? Body diagonal. Clear? Or for this diagonal, we have one more name. One is body diagonal, another one is center diagonal, because it will pass through the center of the cube, right? This one is clear. Next, let me ask, what do you mean by, here we have, I am writing three terms: face, edge, corner. Now tell me, how many faces it has? 6 faces, right? 1, 2, 4 walls, one top, another bottom. So how many faces it has? 6. Now tell me how many corners. Yes, come in. How many corners it has? 8 corners, right? So 4 top and 4 bottom. So it is having total 8 corners. How many edges it is having? 12, right? Edge is this one, right? So 4 top, 4 vertical, and 4 again bottom also, right? So we'll be having total 12 edges. Clear? Now if I ask you, what is the difference between cube and dice? Dice also we have played, right? Ludo, in childhood you have played Ludo, right? It's kind of a cube where numbers are written, right? Or maybe some dots are printed. You can say something like this. Let's say this is a cube, and you can say, let's say if I have 3 here and this side 2. So this is called the dice, right? So first of all, we discuss about what is the cube, right? Basic thing. Now we'll see what do you mean by dice, and we'll solve some couple of questions. In last class, I told you in assignment discussion, we discussed about dice, right? There are 2 types of dice: standard dice and non-standard dice, or non-standard dice is also called the general dice. So this one is clear, right? We discussed about cube. What is cube? How many faces it has? What are the number of edges it has? What is the number of corners it has, right? And this is the basics we have discussed, right? So this is the cube, right? Now we'll discuss about what is dice, right? Now we'll discuss about what is dice. So basically there are 2 types of dice. So dice is nothing but a cube only, but numbers are printed, right? So how many faces we have? 6. So we'll say that you can have numbers like at the top face, you can have number 1, opposite face 2, left side 3, 4, 5, and 6, right? So dice is nothing but a cube only, right? But in cube, it is a general cube. In case of a dice, we will have the numbers written on it, right? So there are 2 types of dice. First one we have, that is standard dice. Actually, why am I telling this? Because when we are solving the question, first thing will be to identify whether it is a standard dice or non-standard dice, right? Then only we'll be solving the question. So in order to solve the question related to dice, we must know that it is a standard dice or it is a non-standard dice. Clear? So first of all, we have standard dice. Another we have non-standard dice. So what is standard dice? What is standard dice? Yeah. Standard dice is that dice in which the sum of opposite faces will be 7. Clear? So here I can say standard dice is that dice in which sum of opposite faces will be 7. Opposite faces will be 7. So let's say if I draw a dice like this, let's say if I have a dice, and let's say at the top I am having 1 and bottom I am having 6. Okay. So if you add this 1 and 6, what will you get? 7. Let's say this right hand side I am having 2, this side I am having 5. So what is the sum here? 7, right? So standard dice is that dice in which the sum of opposite faces is 7. Clear? So let's say if I draw a dice like this, let's say 2, 3, 4. Now tell me, is it a standard dice or not standard dice? No. Is it a standard dice or not standard dice? Non-standard. Because if it has to be standard dice, then if 4 is here, then 3 cannot come here, right? Because if 4 is here, then 3 will come to the opposite face. Then only this will give the sum 7. So from here we can say this is not a standard dice. Clear? So okay, let me give you one more example. Let's say if I have, now tell me, is it a standard dice now? 1, 2, 3. Is it a standard dice? This is a standard dice because if 1 is here, then 6 will come back side. So to identify whether it is a standardized or non-standardized, we should know that sum of adjacent faces should not be 7, right? If any of the condition, let's say 4 plus 3 7, then it is not a standardized, because if 4 is coming here, then 3 should come to the opposite face. Here we are able to see 4 is coming to the adjacent to 3, right? So this is not a standardized, and whereas this is a standardized. Is it clear? No doubt, right? You can easily identify whether it is a standardized or non-standardized. So non-standardized, we have one more name, that is the generalized. How do we identify it is a generalized? It is exactly opposite of this. Here what do we have? The sum of adjacent sides should be 7. So here what will I say? Sum of adjacent side, sum of adjacent faces must be 7. Clear? Sum of adjacent faces must be 7. Okay. Online students, do you have any doubt? So far, is it clear? Balaraksan, Pardeep, Nitya. Okay. Now you see. So here what I have written is sum of adjacent faces must be 7. So let me draw the dice here. Let's say I have a dice like this. And let's say I write 5, 2, and 1. Now can you tell me, is it general dice? Why is it general dice? Because sum of the adjacent face is 7. So we'll call this as a general dice. Let me draw one more dice. Let's say, now is it a general dice? Again it is general dice, because 1 plus 6 is equal to 7. So whenever you are given dice question, the first thing will be to identify whether it is a general dice or a standard dice, right? So general dice is nothing but a non-standard also, right? So now we'll solve the first type of questions, right? And one more thing, before I show you, let's say we have a 3D structure. If I draw the rectangle, so everything will be visible to you, right? Let's say if I draw a rectangle, so you at a time you can observe all of its vertices, right? But if I have a cube is a 3D structure. So first of all, I cannot show you all the 3 faces at the same time, right? Let's say if I'm showing from this side, so which of the face is visible to you? This one, top one, and this one on, right? So at a time only 3 faces will be visible to you at a time, right? Let's say from this end, if I try to show you, so how many faces can you see? Top one? No, I am saying, let's say with the help of board, let's say if I'm writing like this now, like if you are observing from here, then you can observe only 3 at a time. Let's say here I am showing how many faces can you see? 3 only, right? Front one, top one, and that side. Clear? Let's see if I'm drawing some figure on the board. From here now tell me, okay, let me draw it on board. Let's say this one, this one, this one. And let me draw this by dotted line. Now tell me, how many faces can you see from here? First of all, this front part you can see, right? This one, and top part, right? It means that at a time, whenever they are giving the dice, so you will be able to see only 3 faces on, right? And 3 will be backside. You see this one, there will be one face that will be backside, right? From this side, if I see, there will be one face that is the backside. And if I am able to see the top one, then I cannot see that bottom one, right? If I show you something like this, now tell me, let's say you are standing here, how many faces can you see? This one, and this one only, not the bottom one and backside. So it means whenever they are giving the question, at a time they will be showing the 3 faces, right? And they will ask about the remaining faces. Let's say here I have 1, then what will be at the bottom? That depends, right? If it is standardized, then it will be 6. If it's non-standardized, then we'll think about something else, right? So my question is, whenever they are giving a question, so you will be asked whether how many faces you are being shown. You are being shown this condition. So it means you can say the 3 faces at a time. Clear? Next, if I ask you, let's say, first of all, this one is clear, right? Now I'll give you a question. So let's say you have this one. 1, 5, 3. I'm giving the dices, then you have to tell me whether it is a standard dice or non-standard dice. 1, 3, 6. Third one I have. Okay, let's take 1, 3, 2. Yeah, first one. Is it a standard dice or non-standard dice? First one is standard, right? Why it is standard? Because you can say sum of the adjacent is not 7, right? This one is non-standard because 1 plus 6 equal to 7. So it is a non-standard dice. And what is the another name for non-standard dice? General dice. Clear? And in this is standard or non-standard dice? This is again the standard dice, right? Because 3 plus 2 is 5, that is not 7. 1 plus 2, again 3, this is not 7. Then this is also the standard dice, okay? So before we start solving the question, first step will be what? You have to identify whether it is standard dice or non-standard dice. Clear? Okay. Now I'll ask you the question. This one is clear, right? We have discussed about dice. There are two types of dice. One is standard and non-standard. So in question, you will be given only two types of dice. You can number them anything. So we can easily categorize them standard or non-standard. You can write any kind of number. Let's say one you are writing here, anything. So we will be having only two categories, either standard dice or non-standard dice. Clear? So now let's say, I'll ask you a question. Let's say you have a cube, okay? You have a cube like this. And let's say you are allowed to make 24 cuts, okay? The dice question will solve later. First, actually, I want to clear this thing. Let's say you have a cube, okay? So let's say length of cube is anything. Let's say you take 3 centimeter or 4 centimeter. Now the question is, let's say you are allowed to make 24 cuts. And regarding cuts, I already confirmed, right? How will you make the cuts? Either straight cut only, right? This is not the cut. It means you will be making the straight cuts. So how many possibilities are there? You can make cut like along this axis, right? And along this axis. So there are three possibilities. There are three ways in which you can make the cuts, right? Let's say first cut you can make like this, right? Another cut you can make like this, and last cut you can make like this, right? So there are three possibilities because it is a 3D structure. If I tell you there are total 24 cuts you can make. How many cuts you can make? 24 cuts. Now tell me what will be the minimum number of pieces I will get from here. What is my question? Total 24 cuts you can make. What is the minimum number of pieces you will get it from here? 25. So to minimize, I told you what will you do? We'll make all the cuts along the same axis. It doesn't matter we are making like this or like this. So what will I say? So if I explain, let's say you have a road. If I make only one cut, how many pieces I will get? 2 pieces. It means number of pieces will be one more than the number of cuts, right? So if I here ask you, let's say you have to minimize the number of pieces, then what will you do is you will make all cuts along the same axis. So what will you do? You will make the 24 cuts like this. One cut, then 2 cut like this. So how many minimum number of pieces you will get? 25. Next question is, how many maximum number of pieces you can get it from here? Now try this. How many maximum number of pieces you can get it from here? First one is fairly simple, right? Because here we have to minimize. To minimize is very simple. What will you do? We'll make all the cuts along the same axis. So if I am making 24 cuts, so I'll get the minimum, that is 25 cuts. Now my question is, how many maximum number of pieces we can get it from here? To get the maximum number of pieces, what do we do? 720? We'll see. 729. Okay. Any other answer? To get the maximum number of pieces, what we do? We divide the number of cuts equally along the 3 axis, right? It means along x-axis, if I'm making, let's say 5 cuts, for example. So along x-axis, how many cuts I have to make? 5 cuts only. It means I will try my best that the number of cuts distributed equally along x-axis, y-axis and z-axis. So here what can I do? You see, there are total 24 cuts. So how will I divide? 8 cuts this way, 8 cuts and 8 cuts, right? So it means that along x-axis, how many cuts I will make? 8 cuts, right? To minimize, what we do? We make all the cuts along same axis. To maximize, what we do? we divide the number of cuts equally along x-axis, y-axis, and z-axis, right? So here we have 24. So how will I divide 24 equally into 3 parts? 8, 8, 8. So 8 cuts along x-axis, 8 cuts along y-axis, and 8 cuts along x-axis. Now I tell you, if I am making 8 cut along x-axis, then how many pieces I will get? 9. Because if I am making 8 cuts, then number of pieces will be 1 more than the cut. So number of pieces is going to be 9. Along y-axis also, if I am making 8 cuts, then how many pieces I'll get? 9. And here also 9. And then what will I do? I'll simply multiply. Then what will the answer? 729. Clear? This is the first question. My next question is, instead of 24, because 24 is what kind of number? Is it a prime number? It's not a prime number, right? So first of all, tell you what is prime number. Why 1 in itself, right? So if I ask you, is 2 prime number? Prime number, right? Because this is the only smallest even prime number. After then all even numbers are composite number. This is the composite number. So because this 24 I can easily divide by 3 and I can get the equal number of cut. But instead of 24, let's say if I change 11. Now number of cuts we have, that is 11. Now if I ask you what is the minimum number of pieces we'll get it from here? 12. And what about maximum? Pardeep, Nitya, are you guys getting this one? Balaraks, yes. Okay, now tell me, let's say if I have the number of cuts is 11, then what is the minimum number of pieces we'll get? That is 12, right? Is it clear? So now the question is, how will you divide 11 equally along 3 parts? 100? Only 100. So first of all, tell me how you divided the number of cuts. 4, 4, 3, right? Let's say along x-axis you are making 4, then 4 and 3. So what you have to do is, you will try your best. Either it is equal, if it's not equal, then the difference should be minimum, right? It means difference 4 minus 4, difference 0. Here I am able to see the difference 1. One more difference I can say, let's say I can make something like this, 5, 5, 1. This is also a possibility, but what will I do? Corresponding to each case, I'll find the number of pieces, right? Whichever is giving me the maximum number of pieces, that will be my answer, right? So if I have to make 11 cuts, then one possibility is this one, right? 4, 4, 3. Here difference is minimum, right? Here I can see the difference is minimum. Here is 0, but here 5 minus 1 is 4. So I am talking about the difference. Relatively, they are very close to each other, right? It means here they are equally distributed, right? If along x-axis I am making 4 cuts and 3 cuts, it means all are equally distributed. I cannot have 4, 4, 4 because number of cut is odd. So odd divided by even is not possible. You see, if this is the 11, so 11 is what? It's an odd number, or you can say prime number. So prime number we cannot divide by 3 because I have to divide this number of cuts equally along x-axis, y-axis, and z-axis. It means this should be divisible by 3, right? If it's not divisible by 3, then what will I do? I'll try to make it close as possible as I can, right? So this is the only possibility where I can do, right? 4, 4, 3. So now if I am having 4 cuts, then what will happen? Then what will the number of pieces? 5. Here also 5. Here. So what will the answer? So by making 11 cuts, what is the maximum number of pieces that you can get? That is 100. Is it clear? Okay. I'll give one more question. Let's say you have to make 14 cuts. Now tell me the answer. You have to make 14 cuts. So what is the minimum number of pieces? As usual, 15. What is the maximum number of pieces you'll get it from here? Try to solve this question. Aswin, Pardeep, Nitya, Nishant. Now tell the answer of this one. Let's say you have to make 14 cards. Now what will the maximum number of pieces you'll get it from here? Yes. 180? 180. Let's see what about others. 14 is also not divisible by 3. That's what I told. If it's divisible by 3, then it's fairly simple. What you do? You divide by 3, the number of cards can be equally distributed. Here we cannot equally distribute it because here we have to make them equal as possible. We can, right? Balaraksan, Nitya, Pardeep. 225 we are getting, but my offline students are getting 180 only. 245. Okay, let's go. Let's say who wins. 245, 180, 225. Any other answer? 180 only. Okay. 180. Anyone else? Maybe from this side, back side. 180. Okay. Online student, how you got 225?
Sir, 122.
122.
Sir, 120.
Okay, 120. 180. Okay, we are getting more votes for 180. 180. Okay. Okay, let's just check. How you got 180? Anyone can explain from offline? How many cuts you make? 554. And what about who got 245? How you distributed the number of cuts? 644. Okay, we'll see. 8 and 6, 5, 5, 10, 14. Okay. Which anyway, if this is more, then definitely this will be correct, right? Because this is also a possibility, because 4 plus 4 is 8 plus 6, 14. But in this case, we'll find the number of pieces. Okay. What will the number of pieces? If I'm making 5 cuts, then 6 into 6 into 5. Then what will I get? 180, right? Okay. Let's try to find in this case. If I'm making 6 cuts, the number of pieces will be 7 into 5 into 5. Then what will the answer? 175. But this is less, right? It means we have done some mistake in multiplication, right? This is only 175. Here we are getting 180. So it means, how am I supposed to distribute them? 5, 5, 4. Anyway, this won't work. You can see this difference is 0. That's perfectly fine. But 6 minus 4 is 2. But here you see 5 minus 5 is 0. And here difference is 1. It means this will work. Is it clear? Okay. Online student, is it clear to you? Is it clear that 180 will be the total maximum number of pieces? Clear? Okay. Now we'll move to the next question. Okay. Now we'll solve one more interesting problem. Okay. Now let's say this time we'll try to keep it simple only. Let's say you have a cube. Okay. And let's say you have a cube and I'm making 3 cuts along each axis. So how many cubes I'll get in total? Let's say I have total 27 cubes, right? Okay. Let's say I have a cube like this. Okay. And along each axis I'm making 2 cuts. So each axis, if I'm making 2 cuts, so how many pieces I will get along each axis? 3 pieces. So if I have 2 cuts, then along each axis I'll get 3 pieces. So can I say 3 into 3 into? So in total, how many pieces I'll get? 27 pieces. Okay. So can I say at the bottom layer, how many cubes I'll be having? 9 cubes. Let's say in bottom, how many cubes I'll be having? 9 cubes. And the middle layer, 9 cubes. And the top layer also 9 cubes. This one is clear. Now if I tell that, let's say bottom layer, if I give them cubes name, bottom layer I'll be having cubes like this: 1, 2, 3, then 4, 5, 6, 7, 8, 9. So bottom layer, let's say if I give the name of the cubes like this one, can you say this is the bottom layer, right? What will happen to the first layer? Middle layer, you will start from here: 10, 11, 12, 13, 14, 15, 16, 17, 18. This one is middle layer, right? And let's say, let me write the top layer also. That will be 19, 20, 21, 22, 23, 25, 26, 27. This one is clear. Now if I ask you, let's say, first of all, tell me, I started giving name from here, right? So what is the cube number of this cube? 1, right? And what about this one? 27, right? So if I join them, some cubes will be coming, right? All cubes will come along this diagonal. So the first question is, how many cubes are there which lie along this diagonal? 3 only, right? 1, 27, and 1 cube will be here. Now first question fairly simple. Now I am giving you the basic idea, then we'll increase. Then what will I do? Then I'll increase the number of cuts, then it will make it complicated. Now question is, if I ask you sum of cubes, sum of number along this diagonal, along this diagonal, some numbers will be coming, right? It means corresponding to each cube, we have given a number, right? So if a cube is starting from 1, if a diagonal is starting from 1 and ending at 27, so what will be the cube number that will be in the middle? 14. How you got it? You can say, let's say this one is 1, this one is 27. How will you get it? That will be the middle cube of the, that will be the center cube of the middle layer, right? So where is the center cube, middle layer? This one is the middle layer. And what is the center cube? 14. So 1 plus 14 plus 27. Can you observe some pattern? How I got 1 to 14? I added 13, right? And how I got 14 to 27? I added 13. It means that if I am moving diagonally, the pattern you need to observe, if I am moving diagonally, then the cube number, it means I am moving from, bottom layer to the middle layer. This one is the bottom layer, right? I am moving bottom layer to the middle layer, then I am supposed to add 14. But if I ask you, let's say, first of all, tell me what is the cube number here? 7, right? This one is 7. And can anyone tell what is the cube number here? 21. Now can anyone tell from here how will I go there? 14. How I got 14? Here I am adding 13, but here I am, you see, 1 to 13, 14 plus 7, and this one is plus 7, right? Are you getting the idea, right? So this is the basic idea I am telling you. Now I'll make it complicated, right? This one is fairly simple, all of you can get it because there is only one cube in the middle. So it is fairly simple. Actually, in all the cases, you know the corner cubes, right? And easily you can find the sum of the diagonals. Now if I make it little complicated, because here is only one cube. So you don't have to worry about, because in each cases this middle cube will come. If this center cube is coming and rest of the cube number you already know, then you can find the sum easily, right? Now let's say I have 6 cross 6 cube, right? 6 cross 6 cube, right? It means that I have a grid of 6 cross 6. It means each layer, how many cubes I have? 36. It means if I am making 5 cuts, then how many cubes I'll get in along x-axis? 6 into 6 into 6. So total how many cubes I have got? 216 cubes, okay? And likewise I'm numbering them. 1, 2, 3, 4, 5, 6, 7, 8, 9, like this I'm numbering, okay? So how many layers do I have now? 6 layers I have, right? So let's say first layer I am having like this, 1, 2, 3, 4, 5, 6, then 7, 8, 9. So first layer starts from 1 to 36, okay? Second layer starts from 37 to first layer, all of you got it, right? How am I numbering? 72. You see, yeah, that one is correct. You see, first layer I am numbering like this, 6, then I'll give number like this, then it will end at 36, right? Second layer I am numbering from 37 to 72. Clear? So likewise I have given them number, okay? Now my question is, in first layer, first of all, simple. In first layer, what will the sum of cubes that lie along this diagonal? What is the sum of cubes that lie along this diagonal? First layer. So what will come here? 7 will come. 7 or 8? 8 will come. You see 6, 7, then 8. Getting my point? 8 will come. Now tell me what will come here. You see, you need to observe the idea. You don't have to count. You don't have to count. 1 plus 7, 8. 8 plus 7, 15. What will come here? Here? 29 and then 36. So you can easily add. Now my question is, if I go to layer number 4, there are total how many layers are there? 6 layers. If I go to layer number 4, from there, how many body diagonal will be there? 2 body diagonal will be there. If I am talking about layer number 4, there will be 2 body diagonals. Now tell me, what will the sum of body diagonals? What will the sum of cubes that lie along the body diagonal in layer number 4? How will you find? First of all, I am talking about layer number 4. First of all, you should know from which number layer number 4 starts. From which layer? Layer number 1 is fairly simple. It starts from 1 and say 36. So we can easily get the idea. Now, first of all, try to go in layer number 4. Layer number 4 will start from which number? Balaraksan, Aswin, Pardeep, Harshvardhini. First of all, tell me layer number 4 starts with which layer? Sorry, which cube? Are you getting my point? Online students. Once. Balaraksan. Any doubts? Okay. Now, first of all, you are telling I am going fourth layer. It means that first layer ends at 36. Second layer will end at 72. Third layer will end at 108. It means fourth layer we start at 9, right? It means third. Okay. Third layer, you see, first layer will end at 36. Second layer will end at, third layer will end at 108. It means fourth layer will start at 109. First of all, clear? Now tell me where it will end. 144 or 145? 144, right? So 144. Now question comes. In between, how many cubes are there? 4 more cubes, right? If I am having 6 cross 6 grid, then along the diagonal there will be along the diagonal total 6 cubes will be coming. Out of 6 already I know 2, but it means I have to find the cube number of these 4 only, right? So now tell me what process will I do? Simply adding. Like from here 109 plus 7, right? What you are doing? You are adding 7, right? It means I told you, if you are moving diagonally, then what you are supposed to add? 7. 7, then again 7, 7, 7, and 7. So you can easily find. This one is clear, right? It means if they ask any of the row, what you are supposed to do, you first find the corner number, right? Then you start adding 7, you will get all the numbers. Now my question is, let's say if I draw the whole cube, this one, and now tell me if I started the numbering like this from here, right? 1, 2, 3. This one is cube number 1. And what is this one? 216. So if I join this one and this one, then what kind of diagonal is this? Body diagonal. Along the body diagonal, how many cubes will be coming? 6 cubes will be coming, right? So out of 6, 2 already know. Now tell me what will the cube number of rest 4? How will you find? Actually, in last case, what we are doing is we are not moving from one layer to another layer. We are staying in the same layer, right? So we are able to add 7 and get the next answer, because here difference will be 7 only. Let's say this one 6, then 7, 8, 7, but here we cannot add 7. Are you getting my point? Now here you see what will you do. First of all, I'll give the idea, basic idea, then you can easily identify. You see, first of all, I'll draw the first layer. 6, 7, 8, 9, 11, 12. 1 second, just a minute. Here I'll draw. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 3, 4, 5, and at last 36 will be coming here, right? So next we'll start with 37, 38. Then what will come here? 37 and last one? 39, 40, 41, 42. Then 43, 44, and likewise will be getting, right? In this case, what we were doing, we were moving diagonally, but from the same layer. It means if I am in the first layer, so I am searching for the diagonal element in the same layer. Now to get this element, I have to, first condition, I have to go in second layer. First condition. Second condition is, how will I reach there? It means from first, it means if I want to go in the second layer, then what will I have to supposed to do? It means I have to find the cube which is just above the 8. Clear? Which is just above the 8, right? So what will I do? What is the cube number which is just above the 8? That is 44. So first of all, I'll get 1 plus 44. In next one, what I have to do? If I have to find this one, it means which layer it is this? Third layer, right? Third layer, right? This one is in second layer. Third layer, how will I go? Here, first of all, tell you what number will come here. 15. It means from the 15, I have to find the cube which is lies in second layer, which is just above this one. First of all, tell you what is the cube number that will lie just above this one. You see how I got 8 to 44? What number I added to get 44? No, 36, right? It means that you see the difference. If I am moving in the same layer, then I have to add 7. If I am going from bottom layer to the top layer, then what am I adding? 36. You see, automatically number of cube. You see, if I am getting 15, again, how will I get come here? Only 36 cubes, right? If you count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then again, just the top, it will come after 36, right? So it means if I am moving from one layer to another layer, it means if I ask you, what will come just above this one? Simple, right? So likewise, if I say, here I have 15, 15 to what I have to add? 72, right? No, 36 I am adding, I am going in second layer, but I want to go in third layer. So what will I add? 72. Then what will I get? 87. First of all, tell me what number will come here? Here, 16, 17, 18, 19, 20, 21. Now what will I add? Now I am going in fourth layer. So fourth layer, what I have to add? 36 plus 36 plus 36. 108 I have to add, right? So what will come? 122, right? Now let's say, now tell me what is the, what number? No, what number will come here? 28. Now from 28, let's say if I want to find this cube, then which layer I am supposed to go? Fourth layer, right? So fourth layer, if I am crossing one layer, I am adding 36. If I have to go in fourth layer, it means I have to add 144, right? Are you getting my point? You see, this cube lies in first layer. This cube lies in second layer. This cube lies in third layer, fourth, fifth, and sixth. So last cube already know that is 216. So this is first layer. Second layer cube I can easily find, right? This one manually we have to find because we have to analyze that trick. 144 we have got. Now if I want to go in there, how will I get 87? Because at this I am going, from this I am going the third layer, right? So third layer, what will I do? If I am crossing one layer, I am adding 36. If I am going to the second layer, then I'll add 72. So now you easily you can get the answer. Clear? Here? Here something wrong. This one? Okay, maybe we written wrong. Now what will come here? This one is 140. This one is correct, right? 144. Then what will come here? So what you do? You add 72, 87, right? This one is clear. Now what will you do? 72 you will add, right? So 130. That's all. 130. So simple. What you do? This one is 1. Now you get 44. Now what will you do? You add 72. Then 108. Then 144. Then you will get 216, right? Here what is coming? 130 or 128? You see, why are you getting confused? You simply write this. First of all, tell me the diagonal entries of this first layer. So what do we have? 1, then 8, then 15, then 28, then 36. Now, first is clear, right? Now what? 41? Oh, okay, 29. 144 is clear. Now from here you add 72. What will you get? 87. Now add 108 here. Now add 144 here. 144 only because 36 times 4, right? 36 times 4 plus 29, what will you get? 36 times 4 plus 29. So what will be the answer? 170. And last one is already we know. You can do this way also. 36, I am going to sixth layer. So what will I do? 36 times 5 plus 36. So this is nothing but 36 into 6. So that will give me 216. Clear? So easily you can do it. Now if I ask you, let's say this is starting from 1, and let's say if this is starting from 6, then also you can easily calculate. Clear? So it means that what you understood, if I'm moving from one layer to, if I'm going in the same layer, or if I'm moving diagonally, then what happens? If I'm moving diagonally, then I have to add 7. It means, but if I am moving from one diagonal to another diagonal, or I can say if I'm moving from one layer to another layer, then I have to add 36. Clear? Okay. Next, I'll ask you one more question. That is, now we'll solve the question on dice. Online students, is it clear? Bala Raksan, is it clear? Aswin, Okay, now we'll solve the question. Now you see. Okay. Okay, now we'll solve the first type of question, that is, now we'll take the dice question, type 1 question. Okay, so let's say here I am giving you only one dice. Okay, one dice is given, and let's say number also given 1, 2 and 3. Now you tell me what will be the opposite of 3? 4, right? How you are sure whether it is 4? Because first step you have to identify it is a standard dice or non-standard dice. So is it a standard dice or non-standard dice? Standard dice. Standard dice, right? So in standard dice, what happens? Sum of opposite faces is 7, right? If this is 3, then that has to be 4. Okay. Next, if I ask you what is the opposite of 2 here? 5. What is the opposite of 1? First one is fairly simple. So first step is identify whether it is standard dice or non-standard dice. Okay. Next, I'll ask you one more thing. Let's say you have one more question. 1, 3, 5. Now tell me what is the opposite of 3? 4, right? And what is the opposite of 2 here? 5, right? Either we can identify. The first condition is check whether it is a standard dice or non-standard. In case of standard dice, it is fairly simple. What you have to do, you have to subtract from 7, right? If I ask you what is the opposite of 6 here? 1, right? This one is fairly simple. Next question, if I ask you, let's say you have this one 1, 6, 4. Now you tell me, now I'll ask the question, what will be the opposite of 4? And I'll give the options. Think carefully, then answer. Think carefully and then answer. Okay, I'm giving you 4 options. There are 2 types of option: A, B, C and D. Okay, so that is 2, 3, 5 and none. And another I am giving A, B, C, D. Now tell you, let's say I have these options. Okay, so first of all, tell me what kind of dice is it? Standard or non-standard? Non-standard. Okay, in non-standard, what happens? Sum of adjacent side is 7. So you can say sum of adjacent face is 7. But can you tell me what is the opposite of 4? That want to be 3. First condition, right? So in case of a standard dice only, we can tell this is 4. So it is a condition. It may be a possible. There may be possibility opposite may be 2. 3 is also possible and 5 is also possible. But if let's say these options are given, right? Let's say this option is given and let's say this option is given. From this, if I ask you what option will you pick? D you will pick, right? How do you know 2 will come here? Because you see, in case of non-standard dice, it's not necessarily it says every time sum is 7. That won't be possible. It's not like 1 plus 6, 7. This should be 7. No. In any of the conditions, this should satisfy. Let's say 2 is coming here. Let's say 2 is coming here, and if I show you this face, then also it is a non-standardized. 1 plus 6, 7. Then 2 is also coming. If 3 is also coming, then also it will be non-standardized. If something 5 is coming, then also it will be non-standardized. So what happens in case of non-standardized? Uniquely, we cannot determine which number will come to the opposite face. So let's say these options are given. Now, which option will you pick? D. None, right? None of these. And if I am giving you A, B, C, D, now which option will you pick? B, right? Because 6 cannot be possible because 6 is adjacent. So which option will you pick? Option number B. Clear? Yes. Why cannot come? 3. That's what we want. No, 3 can come. No, I'm not talking about this one. What happens? You see, in how do we identify non-standardized? The sum of adjacent faces. If this is 7, then it's non-standardized. If you have 3 here, and if I show you this face, then what happens? 3, 1, 6. It means it's still non-standardized. So for a standardized, what should happen? Sum of opposite face is 7. If sum of opposite face is 7, then adjacent cannot be 7. Here, if adjacent can be 7, if here adjacent is 7, it means opposite will never be 7. Because if I am getting adjacent is 7, then I don't care whether opposite is 7 or not. Is it clear? Because what happens in standardized, corresponding to 6, then 1 should come that side. Corresponding to 4, 3 should come that side. If this is 5, then 2 will come that side. It means that once it is a non-standardized, there is no way we can convert it into standardized. Clear? Okay. Now I'll ask you one more question. Let's say I started giving number A, B, C, D, E, F. Okay. So now tell me, I have numbers like this: A, B, C, D, E, F. So now tell me, and let's say I have B, A, C, something. Okay. Now tell me, what will be the opposite of A? Consider this as a number. Are you getting my point? Let's say A is corresponding to 1, B is corresponding to 2, C is corresponding to 3. Now what will the opposite of A? F. Clear? A is corresponding to this 1, 2, 3, 4, 5, 6. What will the opposite of B? E, right? What will the opposite of C? First one is clear, right? So in the first type of problem is fairly simple. Now we'll increase the complexity. Only one cube is given. After then we'll give 2 cubes, then 3 cubes, 4 cubes, 5 cubes. The more number of cubes you'll get, little bit difficult it will get. So from here, can you say this one is fairly simple? What you have to do is you just have to identify what you have to identify, whether it is standardized or non-standardized. Standardized is fairly simple. What you do, if opposite face is asked, 7 minus that number. If it's non-standardized, then unique answer won't be possible, right? Clear? Now type 2 will do. Let's say you are given the 2 cubes. You are given the 2 dice. Here, how many cubes you are shown or how many dice you are shown? Only 1 dice. Now what you will be given is, you will be given 2 dice, okay? You will be given the 2 dice. First one is fairly simple. Now we'll see type 2. Type 2. Now type 2, there are 3 possibilities. Let's say if I am showing the 2 sides and there is a possibility no side is common, and I mean there is possibility that no number is common between 2 sides. Let's say I have a cube like this. One face, if I show you this one, 1, 2, 3 I am showing. Another face, if I show you like this, then will there be any common number between 2 faces? No common, right? Let's say one face I am showing like this, 1, 2 and 3. So what will you be able to see? 1, 2 and 3. If I hold this way, if I show you like this, then 4, 5, 6. It means in type 2, we'll have 3 model. Between 2 cubes or between 2 dice, 1 number may be common, 2 number may be common. If 3 number is common, it means both are same dice, right? Are you getting my point? So in type number 2, what we'll have? We'll have 3 cases. There is no number common between them. Let's say, first of all, I write model number 1. It means we'll get the model number 1. It means there is no common number between them. Let's say 1, 2, 3. It means I am showing this and this is the same dice, but I am showing the different faces, right? 4, 6, 5. Is there any common number between them? No common, right? So this comes under no common number, right? No common. Now I'll take the model number 2. Model number 2 also, I'll show the 2 dice, but there will be one common number. First I'm explaining the models, then we'll move to the question. Let's say 1, 2, 3, 1, 4, 5. Do you see the difference between model 1 and model 2? Model 1, what is happening? No common number is there. Model 2, one common number is there. Now we'll move to model number 3. Model number 3, what happens? 1, 2, 3, 3, 2, 6. What is model 3? Model 3, it means between 2 dice, 2 common number is there. If I am giving you 2 dice, only 3 possibilities, right? No common number, 1 common number and 2 common number, right? Now we'll solve the questions. Okay, clear? First of all, we have taken the type 1. That is fairly simple. What we are doing there? Simply you are given the dice. You are asked like what is the opposite of this one. You can easily do. If it's the standard dice, 7 minus something. If it's non-standard dice, you cannot uniquely determine the answer. But now we have type 2 where 2 cubes are given. In 2 cubes are given, how many possibilities are there? 3 possibilities. Between 2 dice, no common number, 1 common number and 2 common number. Clear? Yes. 1, 3, 2. This was 1, 3, 2, 1, 4, 5. 1, 3, 2, 1, 4, 5. Okay. Now we'll solve the question. This one is clear, right? Now the question is, so we have seen the model numbers, right? We have seen in type 2, there will be 3 types of model number. Now tell me, let's say I am drawing the type 2 model number 1 question, right? So what we have to do is, let's say you have this one. And let's say this is 1, 2, 3. Model number 1 is fairly simple. if I ask you, let's say two faces I am showing. Now tell me what will the opposite of 1? 6. Simple. What will the opposite of 2? 5. What is the opposite of 3? 4. How are you able to tell that there is opposite of 1 is 6? Because first in model number 1, it is fairly simple. What you do is, first of all, you think whether it is standardized or non-standardized. Standardized. Then even you forget this one also, you can easily answer. Or you can say corresponding faces will give the same answer. You can say 1 and 6, 3 and 4, 2 and 5. Now model 1 is fairly simple. Now comes the next question. Let's say model number 2. Let's say 1, 2, 4. And then now I am giving you, that is, now tell me what is opposite of 4? Opposite of 4. Think and answer. 6. How? No. But I'm not showing there is no 3. Okay, I'll change the question. Okay, 1 second. It will be easy. Actually, it will be complicated. Then one side I'm giving you the non-standard, standard. I'll change 1 second. So if I give you 1 second, I'll change the question. It will be easy. Let's say I have 5 here, 4, 3. Then I have 5, 2, 1. Now tell me. 5. Then here I have 2. Now tell me what will be the opposite of 5. 5, 2, 1. Yeah. Now tell me what will the opposite of 5. How come 6? But if I change 5 here and bring 4 here, now? Yeah. Again 6. No change. Opposite of 3? Opposite of 4? Okay, now we'll see the shortcut also. Now we'll see how can we solve. When there is only one common number, so what we do is, we start from that number and start writing the number in clockwise manner. We start writing the number in clockwise. But the only condition is we'll start from the common number. This is the common number, right? So we'll start from the common number and write in the which way? Clockwise. So first of all, what will I get? 5, 3, 4. Here what will I get? 5, 2, 1. Now what is the, now from here you tell, what is the opposite of 4? 1. Opposite of 3? Opposite of 5? 5 is not possible. So what is the remaining number? 6. Clear? So I'll give you one more question. You try to solve. First of all, let's say I have A, B, C. Okay. A, B, C is given. Now I'm changing A, D, F. Now you tell me what is the opposite of C? D. Think. Opposite of C. What you do? You start from A, right? You start from the common. You write the number in which way? Clockwise. You start from A, write from the. Now what will happen? A, C, B. Here A, D, F. So opposite of C will be D. What happens? See, correct only, right? A, C, B, A, D, F. Opposite of C will be D. Opposite of B will be F. Opposite of A will be remaining one, right? Because we are numbering, right? A, B, C, D, E, F. Clear? Okay. Balaraksan, any doubt? This one is clear, right? Is it clear? Ashwin?
Yes, sir.
Okay. Now if I ask you one more question, that is, let's say if two numbers are common, then what happens? If between two dice, if two numbers are common, let's say I have this one. This is the dice 1, 2, 3, and let's say I have 2, 3, 6. Now tell me, opposite of 2. 6, right? So what happens in 2? When two numbers are given common between two dice, then remaining number will be opposite of each other. Clear? Remaining number. But now here also you can answer, why can't we do this in the shortcut method, right? There are also shortcut we can apply because 2 is common, so we can write 2, 3, 1, 2, 6, 3. We'll see. First of all, tell me 2 is common to 2, 3 is common, then 1 and 6 will be opposite to each other. Clear? So what happens when two numbers are given common, then what we do? That remaining number will be the opposite of each other. Clear? Is there any doubt in this? So now tell me what will the opposite of here. Let's say if I ask you that question, one more question if I ask. Let's say I have 3 here, 1, 4, and one more cube I am giving. And 3, 5, 1. Okay. Now tell me what is the opposite of 4? 5. Now tell me what is the opposite of 3? 3. Opposite of 3. Two possibilities are there, right? So opposite of 3 will be, because if you draw like this, right? So you'll get 3, 4, 1, 3, 1, 5. Clear? So from here you cannot say 1 is opposite of 5, 4 is opposite of 1. But here from here we can easily say, right? 4 is opposite of 5. So 4 and 5 won't come here. So that's why I'm telling, when two numbers are common, then this method won't work, because we are getting confused. 1 and 5, what does this mean? It is telling that 1 is opposite of 5, and what is this? 4 is opposite of 1. So again confusion. But so from here we can easily say, if 3 is coming here, so 4 cannot be opposite of 3, because 4 is adjacent. 1 cannot come, 5 cannot come, right? So how many possibilities we are left with? 2 possibilities. It means what will the opposite of 3? Either 2 or 6. Clear? Okay. Now we'll move to the type 3. When 3 cubes are given, right? If 3 cubes are given, then what happens? Let's say I'll give you the question itself directly. You are shown the 3 faces. Okay. You are given the 3 dice. Then you have to tell. This one is 4, 6, 3. This is one cube. Another cube. This one is the second cube. And here you are given 5, 4, 1. It means they are not different cubes. It means I am showing the 3 different sides of a cube itself. Okay. So this one is second, and this one is the third one. Third one I am having, let's say 2, 6, 5. Okay. Now tell me. Now I'll ask the question. What is the opposite of 6? Think and answer. 1. How you identified opposite of 6 will be 1? You see, from here also you see 4 is not possible, because 4 lies adjacent. 3 is also not possible. So we can say for the 6, what are the possibilities? 4 is not possible because 4 lies adjacent. 3 also lies adjacent. 3 is also not possible. Here 2 is not possible, and 5 is also not possible. Then what is the remaining number? 1. So that we got it. Okay. Now tell me, this one is clear. Now tell me, what is the opposite of 3? Opposite of 3. How can you get opposite of 5? You can use these 2 diagrams. You see, from here you see in these 2 diagrams only one number is common. What is that number? 5. So from here if I draw the numbers in, so what happens? You see 5, 1, 4, then 5, 6, 2. Now tell me what is the opposite of 4? 2. Opposite of 1 is 6, that we already know. And what will the opposite of 5? That will be 3. Clear? Okay. Now I'll give one more question. Now I am giving you 4 cubes. With 3 cubes is fairly simple. You don't think if more number of cubes are given, then it is complicated. Then it is fairly simple also, because we can eliminate the options, right? You see, opposite of 6, 4 cannot be possible. 3 cannot be possible because 6, 4 and 3 lies to adjacent. Here you can see 2 and 5. So what option we are left with? 1 only, right? So if more number of cubes are given, then our question become little easy, right? Okay, I'll give you 4 cubes now, and then I'll ask the question. Let's say 1. Let's say I'll give the 4 cubes. This one, 1, 6, 2. Then I have 4, 3, 5, 2 cubes. This one I have 4, 3, 6. One more cube I am having. That is 1, 3, 5. Okay. Now my first question is, what will be the opposite of 1? 4 cubes you have, right? All of you can see the cubes. Opposite of 1. What will the 4? Opposite of 2 is what? Opposite of 2 is 3. Opposite of 5? 6, right? You see, More number, if more number of cubes are given, it is fairly simple to identify, right? How you got 1, 4? You see, if you see these two cubes, you can easily say 5 and 6 are opposite. You see, in this one and this one, what is common? Two numbers are common. If two numbers are common, then remaining number will be opposite. So 5 and 6 are opposite. This one is fairly simple. How you got this 1 and 4? Second one? Okay. Two numbers are common, right? Here also you see, if two numbers are common, then remaining will be opposite. So you know 1, 4, 5, 6, and definitely 2 and 3 are opposite of each other. Clear? No doubt in this? Okay. Now we'll solve some question. Now actually we'll take some counting question. This one is clear, right? So in cube and dice is fairly simple question you'll get, right? First type of question is you should know what is standard dice and what is non-standard dice. Then we have discussed like what are the different type of questions, right? Like only one cube is given, then what happens? Two cube is given, then what happens? And one more question, cutting questions we have done, right? How many maximum number of pieces you can generate from here? Now I'll ask some question. Let's say you can answer or not. Let's say you have 3 cross 3 grid. It means, let's say you have this one 3 cross 3. It means that, so it means this is 3 cross 3 grid. My first question is, and let's say each length is 1 centimeter. Okay, it means this is 1, 1, 1. First thing, tell me what will be the perimeter of this one. It means perimeter, not this one. It means I'll go like this. It means I have to walk on each path. Okay, so what will be the perimeter of this one? No, what am I telling is, let's say from here if I start, it means that I want to start from A. Okay, so I have to walk on each path. It means like this. So you see 1, 2 and 3 is left. Okay, leave them. Now how much distance I traveled? I started from here. I left this one, right? This one I didn't cover. This one also I didn't cover, and this one also didn't. Now how much distance I traveled? Consider this each length is 1 centimeter because it is a square. How much distance I traveled? 5 centimeters. That's all. I'm asking. I started from A, came back again B. How? Like this I went. Then again came back to A, right? Different answer. 16, okay. 16, 20, 24. How much distance I traveled? Simple question. You see, I started from here. If from here to here, how much? 1 unit. 1, 1, 1, 1. Now you count how many distance I traveled. 23. Okay, let's consider this one also. Okay. 19. Okay, let's write 19 also. I'll ask online students. Okay, Balaraksan, have you understood the question? 19. Okay, let's see. Balaraksan, Aditi, any doubt in this question? Okay, so now tell the answer. So now tell the answer. What should be the answer? How much distance I traveled? Okay, solve him. Okay, okay. Okay, okay. Yeah. So what is the answer? 20. You count, you see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, what happened is you guys were counting this also, right? This one also didn't. You see, I am asking this distance on the blue dotted line only. So 20 will be the correct answer. First one is fairly simple. Next question. Let's make it little complicated. Next, what am I doing is, now tell me how many squares are there? 9 squares are there. Okay. 9 squares or 10. Before you were telling 9, now 14, eh? Change 14 or 9? Okay, now 14. Tell me how you got 14. All of you know the formula. If it's 3 cross 3 grid, then number of square is going to be 1 square plus 2 square plus 3 square, right? So if it's 4 cross 4 grid, then what we do? 1 square, 2 square, 3 square, 4 square. Let's say if it's 10 cross 10 grid, then 1 square plus 2 square, but it will take lots of time. And I have told the formula also, right? What is the formula? You see, I have given this formula, right? 1 square plus 2 square plus n square. It means what it is? It is nothing but the sum of square of first n natural numbers. It means 1 square. First I am squaring the numbers, then I am adding. So what will the answer of this one? You see, n, then n plus 1, then 2n plus 1 divided by 6, right? What is this? This is nothing but the sum of these two. I am writing the number multiplied by next number multiplied by sum of these two number, right? What is 2n plus 1? This is nothing but n plus 1, right? So if I ask you, if I have a 10 cross 10 grid, this one is 3 cross 3 grid, right? If I have 10 cross 10 grid, then what will the total number of squares? 1 square plus 2 square plus 3 square plus 10 square. But manually, if you do the addition, it will take some time. But if you have the formula, easily you can do it. Let's find the, if you see 10 into 11 into 21 by 6. Now, can you solve this one? We can easily solve, right? First one is very clear. Now, from here, if I ask you, how many, let's say each unit you can consider this a 1 unit, 1 unit, 1 unit. Now tell me, how many 3 cross 3 square are there? Only 1 square. If I ask you 3 cross 3 means I'm looking for a square whose length is 3 centimeter or 3 unit. So this is 3, this is 3, this is 3. This one is clear. Now if I ask you, how many square are there which are of length 2 cross 2? It means now I'm looking for the square which are 2 cross 2. It means this is square, maybe this is square. So how many squares are there which are of type 2 cross 2? 5, 4, you see. Okay, 1 cross 1? 9, right? So now you see, when am I writing 1 square plus 2 square plus 3 square? So this will give me the number of square which are of 1 cross 1. This will give me the square which are of 2 cross 2. And this will give me the square which are of 1 cross 3 cross 3. You see, this one will give 1 cross 1. This one will give 2 cross 2. This one will give me 3 cross 3. It means there is only one square which is having length 3, right? Clear? Now if I have, let's say I have 6 cross 6. Okay. If I have 6 cross 6 grid, then how many total square will be there? You can easily count it from this formula. Now my question is, how many squares will be there which is having 3 cross 3 type? Now can you tell the answer? How many squares are there? Are you getting my question? I have 6 cross 6 grid. First question is, how many squares will be there? You have the formula, right? You put n equal to 6, you can easily solve. Next question is, how many squares are there which are 3 cross 3 type? It means I am looking for the square which is having length 3 unit. Only one square. 9. Only one. 16. I am telling 6 cross 6 grid. I change the question. 6 cross 6 grid I am having. Then how many squares are there which is having length 3 unit? Just 4. You see here. You see 1, 2, 3. You see 1, 2, 3. Okay. Now it's correct. 6 cross 6, right? Total how many squares are there? Not 36. Don't say 36. 36 square are of 1 cross 1 type, right? Now if here I am looking for 3 cross 3. First of all, tell me how many squares are there of? First of all, how will I find the sum of squares? Total number of square I'll find like this, right? Okay. So what is 6 square? This is 1 length, right? These are the number of square which is having 1 unit length. This one 2 unit length. This one 5, and this one. It means how many squares are there which is having 3 unit length? That will be given by 4 square. It means there are such 16 square. First question is clear. Now let's make it more complicated. Now tell me, this one is clear, right? Now tell me, how many rectangles are there? How many rectangles are there? First we start with this one only. How many rectangles are there here? Do we see rectangles also? 4 rectangles. 2 only. No, you see, consider this 1, 1, 1, 1. Each is 1 unit length. How many squares are there? Squares are 5. Rectangles are Rectangle are 4 only. Okay. This one is fairly simple. You can easily count. Now I'll make it little complicated. Now question is, let's say you have 3 cross 3. Now tell me how many rectangles are there. First of all, how many squares are there? How many squares are there? 14. How many rectangles are there? First of all, tell me rectangles will be more or less? Okay. Then how many rectangles are there? 18. 10. How come 10? Just 12. 13. 12. How come? 10. Actually, I'm not asking. I am trying to teach you whether you can identify the pattern or not. Because here it is very easy to count. If I give you 6 cross 3 and then I ask you how many rectangles are there, you cannot count, right? If I give 100 cross 100, then you can't do that, right? 20, 22, right? But let's say if I have 6 cross 6, now tell me what is the number of rectangles are here. But in that rectangle 22 you are finding whether they are pure rectangle or square is also included. You see that, you see square is also a rectangle. Clear? Can we say square is also a rectangle? Because square also satisfies the property of a rectangle, right? So in 22 you are telling, is it just only rectangle or square is also there in that? Square is also there. Then if I ask you what about the pure rectangle means, it means no square is there, right? So according to you, what should come? Before you were telling rectangle will be less. Okay, now I'll tell you. First of all, we'll see some. First of all, we have to identify the pattern. Once we get identify the pattern, it is fairly simple. You see, let's see, number of square is fairly simple. How do I find the number of square? Whenever I saying number of square, it means I am not counting the number of rectangles because rectangle does not satisfy the property of square. It means when I am counting the number of square, I am talking about the pure square. So if I am saying if I have n cross n grid, okay, if I am having n cross n grid, then how many squares are there? Formula is there, right? 1 square plus 2 square plus n square. Then what happens? N plus 1, 2n plus 1 divided by 6. Fairly simple. Next one I am telling, if I have n cross n grid, this one is for finding the square, right? If I find the number of rectangles, so rectangle, I think something else will be there. What will happen in the case of rectangle? Square is also included. I am writing this rectangle. It means I am counting the rectangle as well as square also. It means this answer will be embedded into n cross n grid, right? When I am counting the number of rectangle, it means that number of square will also come into picture because square is also a rectangle, right? So here what happens? You will get n plus 1 by 2 whole square. We'll see the proof also. First of all, you see this question, n square n plus 1 whole square by 4. So if someone is asking for a n cross n grid, what will the total number of square? You apply this formula. If they are asking what is the total number of rectangle, you apply this formula. Now what if they ask find the number of rectangles which are not squares? So here you see in this formula square is also there and rectangle is also there. But if I have to find only the rectangles, then what will I do? From this formula I'll subtract this one. Clear? So now let's say this, let's apply this one in this 3 cross 3 grid and we'll see. Let's say I have 3 cross 3 grid. Now tell me what is the value of n here? 3, because this is 3 cross 3 grid. If I ask you what is the total number of square? Total number of square 14, right? Total number of square given by this formula, or you can do 1 square plus 2 square plus 3 square. What will the answer? 14. 3 square plus 2 square plus 1 square. But if I ask you what will be the total number of rectangles, now tell me total number of rectangles, which formula will you apply? You apply this formula, right? Now tell me here what will you put? 3 into 4 by 2. So 12 by 2 is 6. And what is 6 square? 36. Now I can easily tell this 36 is not the pure rectangles, right? In this 36, what is happening? Rectangle is also there and 14 is also there. Are you getting my point? In this 36, rectangle is also there and square is also there. So if I ask you total number of pure rectangles, what will the total number of pure rectangles? Or in other words, I can easily say that total number of rectangles which are not squares. So if they simply ask you what is the total number of rectangles, 36. Now what will you do? You will do 36 minus 14. Now what happened? 22. Clear? Now my next question. If I ask you, let's say you have, let's try to solve this in 10 cross 10 grid. 10 cross 10 grid, or let's say you make it 7 cross 7 grid. You have a 7 cross 7 grid. In this first question, total number of square. Try to find what will the total number of square. You are given a 7 cross 7 grid. What will the total number of square? Apply the formula, right? Which formula? First, second. Yeah. Then what is the calculate and tell the answer? 7 into 8 into 15 by 6. $140, right? Second question. What will the total number of rectangles? You see, once you know this formula, you don't have to draw the diagram and all, right? But for little bit analysis purpose, you might have to draw. 7 cross 7 grid is there. If I ask you how many squares are there which is having length 4 unit, then this one you got, right? 140 squares. This is total number of squares. Now if I ask you how many squares are there which is having length is 4 unit. So what you will do? You draw 1 square plus 2 square and you start counting backwards. 7 square means, so if I have 7 square, it will give 1 cross 1. Then 5 square means 3 cross 3, right? So that's what I'm asking. Then what happened? 5 square. It means there are 25 squares which will give, which is having the length unit 3. If I ask you 4, then you have to go back. This one, total number of rectangles is here 784. Now tell me what is the total number of rectangles which are not square. 784 minus 140. So 784 minus 140. What happened? 644. This one is fairly simple. Now let's make it little complicated. Now if I say this one is symmetric grid, right? There are two types of grid because here also 3, here also 3. Now if I say you, let's say you have a grid like this. 1, 2, 3. Now tell me, this is not symmetric grid. So can I say, first if I write the length, so can I say this is 4 cross 2 grid. Now tell me how many rectangles are here. Now think. First one is, in case of symmetric, we have the formula, right? Yeah, easily apply the formula. Now this is not the symmetric because you cannot put n equal to 4 here. Because this is not symmetric. Squares or rectangles? Okay, let's say. Then squares. This is pure rectangles or just square is also included here? There are two types of rectangle, right? One rectangle which has squares also. One is the square. Okay, first tell me what is the total number of rectangles here, which has squares also. Think about it. This one is fairly simple, right? You can easily do. You have the formula. Yes? You see, in rectangle, what happens? Can I say square is also a rectangle? What is the definition of rectangle? Rectangle is nothing but opposite sides must be equal. So in case of square, also opposite sides are equal. So it means square also satisfies the properties of rectangle. So I can say square is also a rectangle. Clear? In square, we have some additional properties also, but at least it satisfies the properties of rectangle. So I can say square also comes under rectangle. First one clear. But vice versa, I cannot say. Can I say rectangle is also square? No. In square, what happens? All 4 sides are equal, but rectangle only opposite sides are equal. So I can say square is a rectangle, but rectangle is not a square. So that's why I'm saying when I'm counting the square, rectangle won't come into picture because it's 33, changing 30, 33, 23, 30. You are getting 30. How come? If I change it to some other grid, then what happens? You have to observe some pattern. This one is clear, right? Everyone understood a symmetric case? No doubt in that. You have the formula. You see how we are able to get this formula. You see, let's say you have this one only. Now we'll see the formula. Now tell me how many squares are there? 5, right? So that how we are getting 1 square plus 2 square. So likewise, we are derived the pattern and we got this formula. If I ask you how many rectangles are there, 5 will come. No issue, 5 will come. Now what is happening? Here if you count the number of rectangles, you will see 1, 2, 3, 4, right? Total 9, how you are getting? Since this is a including square, you are getting 9, right? This one is clear, right? But what is happening? How can I represent 9? Can I write 1 plus 2 whole square? Right? 1 plus 2 is what? 3. 3 square is 9. So likewise, if you do in case of 3, now telling me how many squares are there? 14. 14 will come. Then again you will add. Then what will you get? 22 you will get. So what will happen? 36. How am I getting 36? That is nothing but 1 plus 2 plus 3 whole square. So if I extend the same logic, you see, if I extend the same logic, if in 3 cross 3, total number of rectangles I am getting, first I am adding numbers, then I am squaring, right? 1 plus 2 plus 3 is square. So likewise, if I have n cross n grid, then what will I do? What is this? This is nothing but sum of first n numbers, right? In first lecture, we have discussed 1 plus 2 plus sum of numbers, then square. And this is nothing but n plus 1 by 2, right? So this way I am getting the number of rectangles. But let's say if I want to find the number of pure rectangles, what am I supposed to do? From this, I'll subtract this one. Now tell me, this will be greater, this quantity or this one? Which quantity will be greater? This quantity will be greater because it also includes the number of squares. Is it clear? I am asking for a given n. You can take n equal to 10, 1000, anything. This quantity is bigger or this quantity? Down one, right? Because this includes the number of squares also, and this only includes squares. It means this has something else, something extra. Is it clear? Okay. Now you tell me the answer of this one. How to find this one? First one is symmetric case. All of you know, right? Now what happens in case of skew symmetric case? Bala Raksan, is it clear to you? Aditi, Arunaditi, any doubts? This one is clear. Okay. Okay. I'll give one more question. So let's say you have a cube. Simple question. Let's say you can do it or not. Let's say you have a cube and you have to divide that cube into 70 identical pieces. Okay, you have a cube and in that cube you have to divide that into 70 identical cubes. Now you tell me what will the maximum number of cuts you need. First one, fairly simple, 69. This one is now what is the minimum number of cuts that you need? This one is little tricky. Think what is the minimum number of cut that you need to divide that into 70 pieces. Think. Just now I told you how we divide. We divide the number of cuts equally along each axis, right? Along x-axis. Let's say if this would have been 69, answer would have been very easy. Divide by 3 will get the answer. But here is some trick. 14 cuts will get, or 15, or less number of cuts. 14 cuts. Can you make less than 14? Is it possible? 14 cuts is possible, but I am telling maximum number of cuts is 69. Obviously, everyone knows like we'll make 69 cuts and it will divide into 70 cuts, 70 pieces. Now, what is the minimum number of cuts I need to divide this into 70 pieces? Think about it. You will get such question in assignment also. Today will you given the assignment, you will get such kind of question because there you have to think. It's not here number theory is also included. You have to think what are the factors of 70 which are very close to each other, right? So you are telling 14 is the answer. So 14, how you have got the answer? 14? 7 into 5 into 2. So how you are doing? So 7 into 5 into 2. This is nothing but 70. But now next what you did? 7 plus 5. But how do you know why you added 7 plus 5? 11 will be correct answer, right? Because these 7 pieces you will get only by making 6 cuts. Are you getting my point? Because along x-axis we are making 6 cuts, the number of pieces will be 7, right? That's the only trick, right? 7 pieces you will get only by making 6 cuts. Here 5 pieces you will get by making only how many cuts? 4 cuts. And 2 pieces you will get by making only 1 cut. So what is the answer? 11 will be the correct answer. Clear? Okay, I'll give one more question. Let's say how to get 120 pieces. How to get 120 pieces by 12 cut? Is it possible? Can I make 12 cut and get 120 pieces? Show me. If yes, then how many cuts will be making along each axis? You can say 120 pieces we can get in 119 pieces, 119 cuts. That is fairly simple. Make 119 cuts and you will be getting 120 pieces. But how to make 120 pieces or how to get 120 pieces by making 12 cut? Is it possible or not? It's not like, sir, I got in 9 cuts only. No, you have to make 12 cuts and say that we can divide using 12 cut into 120 pieces. Is it possible? Then tell me the number of cuts. Along x-axis, how many cuts you need? 5, then 3, then 4. You see? So if I am making 5 cuts, then how many pieces I'll get? 6. Here, 4, and here, you see? Are you able to get it? Clear? So this kind of question you need to have in mind, because here we are subtracting, right? Because number of pieces are given and then we have to count. It's difficult, right? Okay, last question I'll give. Let's say you have total 17 cuts. Now what is the maximum number of pieces you can get it from here? And what is the minimum number of pieces you can get it from here? Minimum is 18. Maximum? What is the maximum number of cuts you can get it from here? This last question. 17 cuts. What is the maximum number of pieces you can get it from here? And answer we'll discuss in the next session. Think and tell me the answer. Okay.